Imagine you return from a trip and discover that your twin brother has aged years more than you have. No, this isn't cheap science fiction. This is a real prediction from modern physics that will make you rethink everything about time. Get shomo. Ready? Because in just a few minutes, your perception of reality will never be the same again. You know that feeling when you're sitting in a stationary train at the station and another train next to you starts moving? For a moment, you can't tell who's moving, whether it's you or the other train. Now imagine that confusion, but applied to time and the aging of two people. That's exactly what happens in the famous twin paradox, one of the most fascinating puzzles science has ever produced. The story begins simply. Two twin brothers, let's call them Albert and Bruno. Albert stays on Earth, living his normal life, while Bruno embarks on a space adventure toward a distant star. But here's the crucial detail. Bruno doesn't travel at just any speed. He accelerates his spacecraft until it reaches 80% of the speed of light. A speed so absurd that it challenges our intuition about how the universe works. Bruno's journey is to a star located exactly 4 light-years away. He goes, turns around, and returns home. When the two brothers reunite, something completely surprising happens. Albert has aged 10 full years, while Bruno has aged only 6. How the hell is this possible if they were both born literally in the same second? The answer is hidden in something Albert Einstein discovered that forever changed our understanding of reality: time dilation. It's as if the universe had a secret regulator that adjusts the speed of time depending on how fast you're moving. The faster you go, the slower time passes for you, at least from the perspective of whoever is observing. Think of it as a cosmic dance between speed and time. For us who stay on Earth watching Bruno, his clock literally ran slower during the entire journey. This isn't a metaphor. It's not an illusion. It's pure mathematics based on the famous Lorentz transformations. Bruno's time really did pass, more slowly, and that's why he aged less. But wait, because things get even stranger. From Bruno's perspective, there inside the spacecraft, he's not the one moving. It's Earth itself that's rapidly moving away. It's as if he were standing still watching the blue planet shrink in space. By the logic of relativity, this would make Albert the traveler, not Bruno. And if time slows down for the traveler, then Bruno should believe that Albert would be younger, in the end. Now you might be thinking, how can they both be right at the same time? How can each one see the other as the traveler? It's exactly this confusion that makes the paradox so fascinating and, at the same time, so revealing about the nature of time. Let's think about this in a more everyday way. Have you ever been on a road where cars pass in opposite directions? To you, they're coming toward you at high speed. But to the driver of the other car, you're the one approaching rapidly. Both perspectives are valid. Motion is always relative. To the observer, that's one of the foundations of the theory of relativity. Einstein established 2 fundamental pillars that support all this apparent madness. First, the laws of physics are exactly the same for any observer who isn't accelerating, what we call an inertial observer. Second, the speed of light is always constant, no matter who measures it or how that person is moving. These 2 seemingly simple principles exploded our understanding of space and time. From these ideas emerges a universe where time and distance cease to be absolute and universal concepts. Each observer measures these quantities differently, and everyone is correct, within their own reference frame. It's as if each person carried their own ruler to measure the universe, and all these rulers were equally valid. When Bruno travels at speeds close to the speed of light, 2 extraordinary phenomena happen simultaneously. First, space compresses. For him, the distance to the star is no longer 4 light-years, but only about 2.4 light-years. It's as if the universe shrank in the direction of motion. Second, Earth's clocks appear to run slower from his point of view. Albert seems to be living in slow motion, but here's the detail that resolves all the confusion. Bruno doesn't maintain the same state of motion throughout the entire journey. There's a crucial moment that changes everything. When he turns the ship around to return to Earth. At that instant, he needs to decelerate, change direction, and accelerate again. And this change completely breaks the symmetry between the 2 brothers. While Albert always remains in an inertial state on Earth, without abrupt velocity changes, Bruno undergoes an active acceleration process. He experiences real forces that Albert never feels. In the language of relativity, this means Bruno can no longer apply the same rules that apply to inertial reference frames. The physics he knew becomes distorted at this crucial moment. It's like you're playing a game with specific rules, but in the middle of the game, the rules change only for you. From the moment Bruno accelerates to change direction, he definitively takes on the role of the traveler. The symmetry breaks, and there's no more contradiction. He really did experience less time than Albert. An interesting way to visualize this is to imagine that Albert sends daily videos to Bruno via light signals. During the outbound journey, since Bruno is rapidly moving away, he receives these signals spaced out. It's as if the videos arrive delayed. Albert's time seems to drag for Bruno. But when Bruno makes the turn and starts coming back, the signals arrive more quickly, as if the videos were sped up. This abrupt change in perception is a direct reflection of the reference frame change that Bruno experienced. It's as if, in the blink of an eye, several years of Albert's life condensed onto the spacecraft's screen. This difference isn't gradual, it's abrupt, marking exactly the moment when symmetry breaks. Although Einstein developed the theory, it was French physicist Paul Langevin who first presented the twin paradox in 1911. He wanted to illustrate the effects of relativity in a didactic way, creating a story that made the abstract extremely concrete. Years later, Max von Laue brought the crucial technical refinement, systematically explaining how acceleration breaks symmetry and resolves the paradox. What makes this story so powerful isn't just the contrast between two clocks. It's the direct clash between our common sense and the limits of physical reality. When we realize that time can pass differently for people who shared the same experience, our worldview transforms completely. The speed of light functions as a universal ruler that organizes everything in the cosmos. It's what forces time and space to adjust depending on how we move. It's not that the laws of physics are wrong or that there are flaws in logic. These changes are natural consequences of how the universe actually works. Think about this. If you could travel at speeds close to the speed of light, you would literally become a time traveler. It wouldn't be fiction, it would be physics. You could visit Earth's future simply by traveling fast enough and then returning. Of course, it would be a one-way trip to the future. You could never return to your own time. The twin paradox reveals a fundamental truth to us. There is no single, universal, and absolute time. Each of us carries our own temporal rhythm, shaped by how we move through space. What we experience in the story of Albert and Bruno is just an extreme version of something that happens constantly, even if imperceptibly. Even right now, as you watch this video, if you get up and walk around the house, technically you'll be experiencing time slightly differently from someone who remains seated. The difference is tiny, impossible to detect without extremely precise instruments, but it exists. Your phone's GPS, for example, needs to account for these relativistic effects to function correctly. GPS satellites orbit Earth at significant speeds and in gravitational fields different from ours. Without corrections based on relativity, positioning, error would accumulate rapidly, making the system completely useless. It's proof that these seemingly abstract ideas have very real consequences in our daily lives. When we understand the twin paradox, we begin to realize that we live in a universe much stranger and more fascinating than we imagined. Time isn't the constant river that always flows at the same speed. It's more like a flexible fabric that stretches and compresses depending on how we move through it. This leads us to an interesting reflection. If time is relative, perhaps we should rethink how we use ours. Each moment we live is unique, not only in experience, but also in its own temporal nature. The time you spent watching this video passed slightly differently for people in different parts of the world, moving in different ways. The true beauty of the twin paradox lies not only in its surprising solution, but in how it forces us to abandon our preconceived ideas about reality. It shows us that the universe operates according to much more subtle and interesting principles than our everyday intuition suggests. Every time we look at the night sky, we're literally seeing the past. Starlight has traveled for years, decades, or even millions of years to reach our eyes. In a sense, we're all time travelers, constantly receiving messages from different eras of the cosmos. The paradox teaches us that there's no single, correct version of reality. Multiple valid perspectives exist, each shaped by the observer's position and motion. It's a lesson in scientific humility and a celebration of the complexity of the universe we inhabit. In the end, Albert and Bruno are more than characters in a thought experiment. They represent all of us, navigating through a cosmos where time and space dance together in ways we're only beginning to understand. Each of us is both Albert and Bruno, experiencing time in our own unique way, while sharing the same fascinating universe. If this video changed your perspective on time, this is just the beginning of a much longer journey of discoveries. The universe is full of mysteries waiting to be explored, each more surprising than the last. Leave in the comments, after understanding the twin paradox, how do you see time differently? Subscribe to the channel for more curiosities that will blow your mind. Leave your like if the content was useful, and hit the bell to not miss any fascinating discovery about our cosmos. Because knowledge is just the beginning.